So we continue with the acidity, okay, acidity of the carboxylic acid. So what makes it acidic, acid, yeah, you know that whenever the ability for the H to go out, okay, in this case in chemistry the acid is the proton donor, able to donate the protons, okay, that is actually we classify it as acid, okay. So we have for instance in this case here, when the H go out combine with the molecule of the water to form the hydromium ions, okay. So that is for acid, okay. The carboxylic acid are weak acid which partially dissociate in aqueous solutions. It is more acidic than phenol and aliphatic alcohol. Just long story short, the ability to give out the H plus, okay. So when put in the waters, the H plus, and then we will create another ions, okay. This is the carboxylate ion. Alright, so for the second one, we can see in this way. For example, we have the alcohol, okay, O minus in the H plus, and this one is the carboxylate ion with the proton, okay. Why carboxylic acid special? The answer is because of the stability. The stability of what? Okay, the stability of the carboxylate ion, okay, the RO and also the RCOO. So it is just become between the RO and the RCOO minus, okay. In carboxylate ion, the negative charge doesn't stay on one oxygen. It spread out, it would localize over both oxygen atoms, such as this one. If you move around to stabilize itself, so the spread out charge is a very stable charge. And the most important reactive features of carboxylic acid is the OH polar bond, which is readily keep with the base. Alright, so carboxylic acid are strong organic acid which is readily react with bonded slurry base to form the carboxylic ion, meaning to say this one will be go out easily. So this, while on the other hand, is very stable due to its resonance structures here, okay. This is so this happy ion, because it is happy, stable, the molecule willing to give H plus. So more stable, the stronger the acid is. Stable on its own, so it can give out the H plus happily and easily. Alright, so we look at when comparing, for instance, we have carboxylic acid. This is actually phenol, this is just alcohol. This is methanol number 3. So we have 1, 2, 3. So we know that Ka higher, pKa lower. So acidity increase. The lower the pKa value, the acidity will be increasing. So we look at this chart, okay, where it suggests the strongest are carboxylic acid because it can form stable resonance. This one is stable resonance structure, so the H plus will go out easily. Okay, it's very happy to go out. Okay, it can stay by its own self, the stable resonance. And then go to this one, the alcohol. This is actually the R, the RO minus and also the H plus, yeah. So the alcohol is actually the weakest because no resonance structures and unstable. While on the other hand, if we have the phenol will have a certain resonancy, okay, but not as strong as the carboxylic acid, okay. That's why it lies at number 2, okay. It's, if you still remember, this is what we call as the alkoxide ion. Sorry, this is not alkoxide. This one is the alkoxide ion, okay. This is the phenolxide ion. Phenolxide ions are more stable than alkoxide ion, okay. Alkoxide ion is not stable by resonance structures, but this one, it has the resonance structures. Alright, so we go to the next slide, okay. So carboxylic acid are generally stronger weak acid than alcohol because of the delocalizations at carboxylate ion, the resonance structures, okay, it becomes stable. Alright, all these are redundant lah. the resonance structures, you can have a look again. Alright. Yep. So the factor that affecting the acidity, okay, if you can see here, not all carboxylic acid are equals. Yes, group attached to the acid can make it stronger or weaker. So it's a push and pull game of the electron. So it depends on what types of group that adhere to the carboxylic acid. Okay, to make it, whether if you still remember whether it's an electron donating group or electron withdrawing group. So we look at it one by one here. So for instance, we have electron withdrawing group in this case. For instance, we have this is the haloalkane. Okay, haloalkane group attached to this one here. Alright, what happens is it will tend to pull away the electrons. Okay, when it's being pulled away, okay, because of this is the halogens are high electronegativity, so it helps spread out the negative charge, so the electron will be pulled over this side much more, so the H plus will go out easily. Okay, so stabilize the ion, the stronger the acid. So what we can say is acidity of carboxylic acid depends on stability of the carboxylate ion. So it depends on, if we have this one only, so the pKa value is 4.75. But if we add halogen, bigger halogen, so happen is it will tend to, this one already will pull even more. Okay, so this one will go out easily. This one just a little bit. Alright, so go to the next one. So this is basically what we call as the Corins effects. Yeah, the Corins effect. Okay, if you look at here, the Corins effect is chloroethanoic acid stronger than ethanoic acid. Okay, because of the pooling effect. The Cl pull the atom's electron density, make it super stable. Alright, make it super stable. And if we look at this one, if we have more corins, okay, more corin, 1 corin strong, 2 corin is stronger, 3 corin will be super strong. Alright, so more corins, then much more easily for the H plus to go out, because all these are very stable already, it will stabilize itself. Yeah, and yeah, this is the same things. Alright, this one, if without anything pulling, so it actually in this direction, but if we have the corins or the halogens groups, this is the pulling effect. Yeah, and also the distant metal, also the distance is, the closer the electron withdrawing groups to the C double bond OOH, the stronger the effect. Yes, and if it is more far away, the pulling effects will be fit with the distance lah. Okay, so even though it looks like the same, but because this is far, so the pulling effect is lesser, so less acidity. Okay, so this can be illustrated in all these examples. Yeah, if these positions and these positions and this position, the acidity will be differences, even though the number of carbons is the same. Okay, this is more examples that student can have a look on your own. Definitely you can have a look on your own. And acidity of carboxylic acid depends on the stability lah. Depends on the stability of carboxylate ion. Alright, the conjugate base. So electrons withdrawing groups, the EWG decreases the density of the negative charge of the conjugate base, thus making the conjugate base more stable. Okay, this is for instance, if we have all this here. Alright, so this is the electron withdrawing group. This is actually the same as what we had discussed just now. Alright, so if we have electron donating group, just the R group itself, R is actually pushing in these directions. Okay, so this will, the effect is they crowd the negative charge on the ion. Okay, and then destabilize the ions and weaker acid. Alright, so the trend is something like this, no? Okay, methanoic acid has no Pushing's alkyl group. It is the strongest. Okay, ethanoic acid has methyl group, Pushing's weaker. Propanoic acid, it is even weaker. Okay, because you have the more R group Pushing. It is electron donating group, make it less stable. Okay. And electron donating group increase the density of the negative charge of the conjugate base. That's why it is less stable, okay, such as the R groups. All this you can have a look on your own, essentially almost the same. And then acidity in aromatic rings, also you have learned about this in benzene, topic for benzene, yeah. Okay, and if you have this one, this is stronger because it's help to withdraw. This is weaker, okay, because it's donate electron, decrease the acidity. So electron withdrawing groups, the stabilizer, strong acid, yeah, deactivating the ring, stabilizing the anion, then the stronger acid. Okay. While on the other hand, electron donating groups, and it is weaker the acid. So destabilize the anion, so it become the weaker acid. So all this you can have a look on your own, and I actually leave some questions for you to do it. Okay, please do the exercise, and we shall continue our discussions on the preparations of carboxylic acid.